I'm Dan. I'm a full stack data scientist, and I lead a team of machine learning, applied machine learning scientists in Data Valley people. And what about you? So, put your hand up if you work in the data space. So, data scientist, data engineer, software engineer, data science team, project manager. Okay, a bit higher, a bit higher, a bit higher. Okay, great. And no, keep it up, keep it up, keep it up. Keep your hand up if you've been doing that for more than 2 years. Okay, keep your hand up if you've been doing it more than 4 years. Okay, 6 years? Okay, big 10 years? Oh, nice, so 10 plus. Okay, great, that's cool, that's cool. Nice, nice. So we've got a nice mixture, some really experienced people. Great, I'm looking for, cool. So, building a minimal data science platform. This is it. So, just stop whatever you're doing in your data science teams and take 2 months off, build this, and everything's going to be awesome. It's going to be great. You're going to be super successful. Cool. That's it. You know, in the short talk, no, not quite. So, why that's not a good idea? So, I'm saying it's not minimal in that different data science teams, different projects, they might not all need the same infrastructure to support those projects, and also, it's not motivated. You know, our time and resources precious, and we should only be building stuff that is definitely going to deliver us some value in our endeavors to leverage data in our business. So we're going to retry with that minimal and motivated mindset. So this is a brief summary of what we're going to go through. Part 1 is going to be the setup. Part 2 is going to go through sections of the platform in a motivated and minimal way. Okay, this is like a meta slide. These slides are both a presentation and meant to serve as like a reference document. So some of the slides will have a lot of content on them, and I'm not going to talk about that content because it's like also useful if you want to go back and look and think, oh, I want to implement that in my team. I can go and have a look at the resource of that slide. So if you want to look at the slides during the talk and where you want to spend a bit longer on the slides, you can do that by going to that link that just goes to Google Slides and public. But just so you're aware, some slides might seem like a skip tip if you're going to call a reference but you in the future if you want. Cool, so setting the scene. Let's suppose we're the data science team for an ice cream company. We make our own ice cream, we buy ice cream, and we sell it. So we've got like 10 ice cream stores in the UK, and this is our business. And we're the data science team, and we're tasked with leveraging data and AI to deliver business value. That's the scene. Okay, now we want a starting point for our data science team, where we're at right now. And this is it. This is the current general minimal data science platform in the ice cream company. It's me, and my laptop, and a snake, which is some Python code. So this is where it started. And yeah, that does say level -1, and we'll get to the reason why it's -1 there. Okay, cool. Well, let's actually give it some more context. So there's the data science team, and then that's how we interact with the rest of the world. We need to interact with the rest of the world, so we will, from my laptop, maybe pull some data from another business system. Maybe we'll get the revenue for each of the stores on a weekly basis. Yeah. Maybe we'll interact with some external systems. Maybe we'll have like a weather forecasting API that isn't our business. We'll pay and we'll use it to get a weather forecast. But maybe it depends. Maybe if it's going to be hot the next week, that's really important if you're an ice cream company selling ice cream. And then lastly, we actually, anything that we produce, like predictions or forecasting, we need to make that get into the rest of the business somehow to deliver it back, right? So those are the 3 ways of interacting with the rest of the world. Okay, so this is going to be our methodology throughout building this platform. So for each stage of the platform, we're going to go through this cycle. We're going to identify a change, the team is going to grow or the project is going to grow. We're going to identify a pain point that change is created, and I'm going to suggest a solution for fixing that pain point. Okay, so this is where it's going to be this repeated as we build up the platform. Okay, what you should try to get out of this. If you are early on in your career, try to get the conceptual understanding of each component and what that component is used for, why it's valuable, and how they connect. If you're intermediate, maybe go into some more of the details, like some different tech options that you're considering, and then more detail of how the stuff interacts actually in practice. And if you're advanced, consider the nuance trade-offs. Please feel free to jump in and share your experiences, suggest and debate the tech options if you've got opinions about what good choose and what bad choose. Cool. Okay, so now we're onto the platform bit. So now we're into the meat of the presentation. This is where we're at, level -1, and this is our first iteration. So the change, we're going to get new data scientists in our team. We've grown to 3 data scientists, let's say. The pain point, we're sharing code by sending, we want to share code. How do we do that? Has anybody, put your hand up if you've ever shared any code via email? Yeah, how did that go for you guys? Badly, yeah, it's painful, it's painful. So, our solution is to use some version control software like Git and have some our repository hosted on GitHub. So, this is us at level -1, and this is us, we just upgraded to level 0. So, now I'm less important, we've got a few laptops for a few data scientists, so we've got one Python Git repository. That's our platform. And actually, a lot of teams do a lot of value with just this. You know, they run stuff on their laptops and they have a Git repo. Nice. Okay, let's go again. The new change. The data size gets bigger. Let's say our forecasting. Okay, I missed a bit. Let's say the very first project we do is the execs of the ice cream company. They say, we want you to forecast the revenue for each of the stores for the next week. So every Monday we want a revenue forecast for how much revenue that store's going to bring in, because we need this for cash flow planning. Okay? That's all well and good. And we did that with level 0, right? That's fine. We can do that. We run it on our laptops. We get the data from accounting. We run our laptops. Fine. Okay. Now they say that's all good. Now we want you to, for each product in each store, forecast the revenue generated by that product. And then so suddenly our data, which was a time series of 10 stores going back in time, is now a couple of thousand products, and it goes back 2 years, and they want forecasts for all those products. So our data size got a lot bigger. The pain point is it's slow and painful to share data. Again, anybody ever done data science by receiving an email from a different business, from a different team in the business, and done something with the data and emailed it to somebody else? Yeah. Again, painful. So the solution is we're going to use a cloud storage bucket, and we're going to have a single place where we can push data to it and pull data to it from it, and it's nice and efficient. So this is our first platform component slide. It's going to be one of these for each component. And it's going to be an outline slide for this particular component of the platform. So the purpose of cloud storage, or the storage component, is that it's a single place where we store all the outputs, all the results, all the intermediate data, and it enables the rest of the business to access the valuable outputs we're creating, like forecasts or recommendations. So some tech options, and we're just going to do a storage bucket, is what we're going to do. So, cool. This is what it looks like, though, hard to see on the below your screen, but if you were to make a storage bucket on Google Cloud Platform, this is what it looks like. You go, you click, you write your bucket name, and you press create. So you've got a thing in the cloud, like Google Drive, and you can push it more data to. Okay, so this is where we were at, and now we just upgraded our platform. So this is our level 1 platform with a nice big storage bucket, stores all our data. The execs can read our forecasts directly from storage, so we don't have to send an email anymore. And the finance team can put their all the details about sales of individual products for each of the stores directly into that bucket if we ask them to nicely. So we don't need to do email anymore. So we've solved that pain point. Nice. Okay, cool. The change. The team is now working on many projects at once. So let's say we've been doing this for a while, we're doing pretty well, the business likes us, and we've expanded our projects to multiple. We'll speak about that in a second. This pain point is that we can't share code between those projects because they're all in different repositories. So say we made a new Git repository for every project, can't share code. They all have different conventions, different ways of working, and different tools. And every time we want to start a new project, we have to do all that setup time every time. Anybody ever experienced anything like this in your teams? It's a bit more. Put your hands up if you have. So I've seen a lot of teams really struggle with this one. Okay, I love the cheers as well. It's like cheers to that. Drink my glass to this particular problem. This is a really acute problem. So one solution that I'm suggesting is to implement what's called a mono-repo, a mono-repository. So actually, we're going to dig into this a little bit more because it is it's not unique to data science teams, but not all development teams work on many different projects. If you're building an app, you kind of just got one repo and one app. But if you're a data science team, you're often doing different projects for different parts of the business and different endeavors. So this many projects thing is not unique to data science, but is a definite problem for data science teams. Your projects, I just blasted down all the projects I could think of that you could do in an ice cream company. And actually, there's probably loads more. We could think of loads more, right? So that's already like 10 or something. What do you need to deliver a project? I blasted down a variety of stuff that you might set up to deliver a single project. So you might make a Git repository for that project. You might want some code quality tools like linting and unit testing. You're going to have some kind of dev environment and production environment. Your package management. And you're going to need like authentication and credentials. So there's a whole load of like peripheral stuff. Okay, now do that for every single one of the projects that you're doing. And it's like really painful. Like super painful. Okay, so the challenges of many projects. Duplicate project setup time. You can't easily share code between repos. So like your code that talks to the storage bucket to pull and push data, you can't write that in one place and use it in all your repos easily when you have many repos. So you might just rewrite it, copy and paste it, which is always a bad sign in programming if you copy and paste the code everywhere. And lastly, every project has the possibility of different standards. So you might be writing some code on project A, and that all works well. Then you go to project B, and suddenly the code quality linting format complains at you because they use a totally different code style. So that's a big brain drain when you're trying to cross between projects. Okay, I'm skipping this. So this is our iteration, and this is a solution. So it's a mono-repo. So its purpose is you have one place that is going to contain all of the code for all of the data science team projects. That includes like cross-project utility code. So that code which is like pushing and pulling to the data storage maybe, or doing general functional stuff that you want to do all the time. You only have to write it once now, and all your projects can use it. Obviously, it has your project code in it, and then all of that infrastructure stuff, like your unit testing framework, your deployment stuff, like the Docker file, which we'll talk about in a bit. You only have to do it once, and it's all shared across all your projects. You get this consistency. So, how to do this? You can like make your own, and I'm going to show you one example. I did this to my team, and they pushed back and said you don't have to do this, and you should make it very clear that there are some trade-offs here. So this is like this particular component is like one ultra important because your code base is where you really develop your long-term value. Like your code is the most valuable bit of what you're doing, and so making sure that this works well and it's going to be maintainable and user-friendly and valuable long-term in the future is really critical. So like this particular component, take your time thinking about it, do some research on mono-repos if you want to do that. Another way you might be able to resolve those pain points is, has anybody ever heard of cookie cutter? Like a tool where you can like make a patch, like it's a template for your projects. So that might resolve the different convention problems. And then sharing code. Has anybody ever, who knows what PyPy is? Okay, I mean, if you don't, you probably do, if you've ever done pip install anything, you've spoken to a PyPy server, which is where you host Python packages to then install them. And you could run your own like company PyPy server. So if you wanted that utility code, where you're using talk to storage bucket that all your projects want to use, you could write that in your own little, like ice cream utility storage package, right? And then internally in your company, when you have all your permissions set up correctly, you can install ice cream utility storage package. And that's a nice way of doing it, but then you have to like set up and maintain your own Wi-Fi server with permissions or that kind of security. So there's trade-offs here. But really this is like one to do some research on and not just dive into and take into consideration time with it. Okay, so this is taken from, when you get the slides at the end, which they're all public, you can see at the bottom there's like references to this stuff, so you can find where it's coming from. It's from a really nice blog post from a company where they explain how they do their mono-repo. I really like the way they structure it. Just really quick, this is like project 1, project 2, then they have all the other projects. These libraries, this is the equivalent of our ice cream utility storage package, right? And this is going to be shared across all the projects. And then all of their like tools, like their code quality tools, their unit testing codes, it all lives in one section here. So it's all shared nice and easy in this way. But again, if you're interested, definitely check out this blog post. It's a good one. Cool. Okay, so this is what we look like, level 1. This is the intermediate with all our many Python repos. This is painful. And now we just have one nice repo, and we resolve that painful. Cool. Okay. New change. Now we're using some big bad models, like transformer models. They need massive memory usage. They need GPUs. Our laptops are getting fried. Anybody ever tried running, a model that takes 3 days to train on their laptop? Yeah, totally. It's painful. Super painful. It's all going well, and then you forget to plug it in for a bit, and it turns off, and you've lost all your training history. You've lost like 2 days of rinsing your laptop time. So let's use some cloud compute instances, like cloud servers. Great. So this is the component for the compute. Its purpose: runs the code you give it when you tell it to run it. There's a lot of tech options here, from just using like individual virtual machines to Kubernetes to serverless compute. You can check that out. The main remark here is the simpler the better. Like, you just want to just say, hey, this cloud computer, just run my code and just do the job, and no other complications in the way. So we can upgrade again. Nice. So you see we've like replaced our laptops here with this big compute blob, which is cloud machines that are powerful. We can turn them off and on, and they're cheaper, and they stay on all night, on the laptop. And that's now replaced interacting with the internal business system as well. So, we talk to the rest of the business through these servers now. Cool. Nice. Now we're using cloud compute. Now we have this new pain point. Anybody ever had some code that runs on their laptop, and then they try to run it on a cloud server, and it didn't work? Yeah, painful, not fun. Okay, cool. So now we're going to implement what's called continuous integration and continuous deployment using Docker and some kind of cloud build service, right? Okay, really quick. Put your hand up if you have ever heard of Docker. If you even heard of it, it works. Okay, put the hand up if you've ever built a Docker image. Keep your hand up if you ever built a Docker image. Okay, nice. So, what a Docker image is like a lightweight, shippable box that contains everything needed to run a piece of software, making it easy to use across different computers without any setup hassle. So the crucial bit is easy to use across different computers. That's what makes this thing valuable. It's in quotes because I asked you know what to help me write that. So ChatGPT. Cool. So now you know what a Docker image is. That hopefully helps plug into what I'm going to say Docker image a lot. So I just want you to like really get in your head what that was before I start saying it. So the purpose of the build component is it's going to take the code in our mono-repo, and it's going to build these shippable, nice, easy to use software packages that run well on all computers. It's going to build these images, which are kind of, you can just think of them as like a file. And it's going to push them up into the cloud, ready to be used in that compute system. So then we're not going to have this problem of, oh, my software runs nice on my laptop, but doesn't run nice on the cloud server. We're only going to run Docker images which run nice everywhere. Cool. Okay, so that's called like containerisation. Is Docker is a containerisation technology, and the other part of this is like the build component. So we've got the Docker images, and then we want the build component, which is kind of, again, it's just a server that will run some commands that we specify. Hey, whenever there's new code, rerun these set of commands. So whenever there's new code, make a new image. Make a new image and push it up into the cloud. Okay, so this is what a Docker file looks like for anybody who hasn't seen it. So you write this code, and then you say, hey, Docker, build my image. And after it's done those commands, you get this like file which is a nice wrapped up container software ready to go. And you can't read that. You can maybe read this. This is a GitHub action like YAML file, which is like which is the build component of it. So this says whenever there's a new pull request or new code gets onto the main branch, then do these steps. And the steps are install the dependencies and run make. But it could be build a Docker image and push that Docker image. And it'll run all the unit tests and any kind of code quality stuff will all happen in there. Nice. Okay, cool. So we're getting pretty big and sophisticated now. Anybody want to just jump in with any questions? Any burning questions? Or should we just keep powering on? Okay, let's keep powering on. Keep going on. Okay. So the new change after that last change, we're now using a lot of cloud infrastructure. There's quite a lot of stuff going on here. So the new pain point is it's hard to manage all that cloud infrastructure. There's no record of what's there. There's no change of approval process. There's no visibility into what our platform is, other than my kind of sketchy diagram, right? So anybody ever had this problem where they're trying to maintain a lot of cloud infrastructure? People are going on and changing stuff. You don't know they've changed it. Stuff breaking. You don't know what's going on. You sound like you've had some terrible times with it. Okay, maybe you need to have like a therapy session afterwards to talk about it. Okay, so a solution is to use a technology called infrastructure as code. So I'm going to explain this. So infrastructure as code, its purpose is you have a code specification that's kept in version control, and then you have this piece of software which is going to talk to the cloud platform and say, hey, what have you got? And it's going to say, I got a storage bucket and I got a cloud server. And then this piece of software is going to go cool, and it's going to look at your code specification and be like, hey, what do you want? Oh, you want a storage bucket, and you want a cloud server, and you also want, another cloud server, and then this software is going to go, oh, they're not the same. So I'm going to tell the cloud platform to build that thing, right? And so it's keeping your code specification and infrastructure. It does all the work of making that match what's actually in the cloud, right? So the usual my go-to would be Terraform. Is the name of that particular particular infrastructure code technology. There are some other ones. My main remark here is, if you have a data science team which is not super software engineer heavy, they're quite science heavy, and say they're more academic than they are engineering, this can be quite a big hurdle doing this for the first time. So setting it up and just getting your head around it, it's like a new language, and it's a different way of thinking, you're interacting with all this infrastructure that you might not be that familiar with, but it really pays huge dividends down the line. From not only a personal perspective as an engineer, but for the team, for the whole business. Often data science teams might work with, they say, hey, yeah, if you want infrastructure, you speak to DevOps. So you go ask DevOps for a new server. This is super painful to work. This inter-team dependency. If your data science team needs to be self-sufficient, you can go way faster, it's way more satisfying, you have way more control, you're not bugging somebody else who doesn't want to hear from you to do stuff that's integral to you actually delivering value in the business. So, yeah, it is a big hurdle if you're unfamiliar with it, but hopefully the thing I recommend would be ask the DevOps team to help you get good at this, not do it for you. You know what I mean? Because this is what they do. DevOps just do Terraform all day. So get them to help you set it up, get them to give you a bit of training, and then hopefully you'll be self-sufficient. And if you ever get stuck, you can go speak to DevOps. Cool. Okay, this is what a Terraform file looks like. This is that code specification infrastructure. This is what happens when you say, hey, Terraform, apply my, check they're the same. Check that what's in the cloud is the same as what I want in my code. It will go, oh yeah, an execution plan has been generated. Terraform will perform the following actions. It will create this thing because it was missing in the cloud and you said you wanted it in the code. Cool. So, nice. Now we're getting real snazzy. So now, everything in this blue box, which is all cloud infrastructure platforms, is being controlled, specified, and also deployed by this infrastructure code repository, right? Nice. So now it's all version controlled, there's pull requests, there's visibility, there's approval process. So we've resolved that pain point. Okay, we're getting there. Okay, now we're a real sophisticated data science. We got build processes, we're doing all kinds of work, we got models running on GPUs, we're churning out with awesome forecasting predictions, we're doing really great. But we got loads of projects, and we're running this stuff all the time. The pain point is, I'm still waking up at 7 a.m. every morning to press, forecast tomorrow's revenue, right? Which is annoying. But even on Saturday and Sunday, I've got to do this. It's like a nightmare. Not only do I have to go at 7 a.m., I'm also making mistakes. I trigger the wrong job. I trigger the jobs in the wrong order. It's annoying, it's wasting my time. So all this, like, I want this process to run at this time, we're gonna control all that with an orchestration system. It's gonna automatically do all of the triggering and the management of all of the pipeline jobs, which is basically what data science projects are. You read some data, you compute something, you put some data out there. We're gonna use a nice tool for it. So, the orchestration component, it takes DAGs. Okay. What's a DAG? So, this is a DAG, which stands for Directed Acyclic Graph. It's just kind of like a graph that you're looking at. This is a DAG for making pizza, actually. So you kind of, hopefully it kind of looks intuitive. You make the crust, and then after you make the crust, you apply tomato sauce, and after that, you can add all the ingredients at the same time. And while you're doing that, prepare the oven and bake pizza. Now, I don't know if there's any like pizza aficionados in the audience who actually would look at that and say, if you added the cheese at the same time as the mushrooms, that's actually atrocious, and that's really bad pizza. You should add the cheese first, and then probably the olives, and then the ham or something. Could be. So I don't want to offend any pizza chefs in the audience, but hopefully it serves as a good example of what a DAG is. So this is baking pizza. A data science version could be pull the historical revenue data for all 10 ice cream stores, train the model on the latest data, predict forecasts, write the forecasts to the storage bucket. Yeah? Cool. Okay, nice. So it takes DAGs, those pipeline specifications, and then it does all of the work of scheduling, when to run them, like doing backfilling, doing when they fail, it might make retries, it will keep a record of all of the jobs. So does all of that work that now was before in our heads, now it's just in code and automatically doing it. So tech options, Airflow is kind of the gold standard, which maybe for some of you, there's a lot of like competition in that space now, so there's some other ones you can check out, Prefix and Dagster, which look good. Okay, cool, yeah, that was DAG. This is what a Airflow DAG file looks like in Python, so it's Python code. That's important. This is what the Airflow like UI looks like. So you've got the software managing all your pipelines. It's nice to have a nice like user interface. You can go and look at what's happening, see what's ran, see what's broken, that kind of thing. Okay, great. Nice. Level 5, level 6. Okay, this is the end platform. We made it. We made it. Thanks for sticking with me through all of that. That was great. So how do we do? Let's like reflect on that whole process. So minimal. Yeah, I think the platform at each point was just what we needed. Nothing more, nothing more. That's what we're trying to avoid. Extra stuff that was pointless to build and wasn't helpful. Was it motivated? I feel like pretty motivated. At each point, I tried to give it like a really clear pain point, and we were trying to resolve that pain point, not just build stuff for the sake of it. And lastly, a bonus one is that it's modular. So you can mix and match any of those components as you like. So I presented it in this order, but actually you could have done it in any order. And again, I would suggest you motivate it by solving your team's biggest pain point first. So if you are running loads of models on your laptops and just taking forever, set up the compute engine first, right? And resolve that issue as your immediate thing to do. And then reflect back and think, okay, now what's holding us back in the data science team, and try to resolve that with some extra platforming. Okay, nice. This is just a slide for your reference. It's basically that's all that platform and all the component slides in a single image. It's like a good reference image. Okay, what about off-the-shelf platforms? I hear you all screaming, right? There are platforms by each of the 3 main cloud providers provide like an AI or machine learning platform that's supposed to be everything, all-encompassing solution for it. They could be good. I think if you're a massive team or you're a multiple data science company and you really want consistency and you want this off the shelf and you need like lots of, you're doing loads of complicated stuff straight away, then maybe it's a good idea. Most teams that I work with aren't that big, and they're often overkill for what teams need. They don't have the flexibility, and they're not modular in that way that we were talking about. So you can check them out, but they're often like a really big upfront investment that you might not need at the initial time you're doing your data science, right? You might just need yourself a laptop and a server. That could be it, And this is going to be a lot more than that. Okay, nice. That was it. So yeah, thanks. Hopefully I wasn't too slow. It's a little bit quiet, so we're going to get Mike sorted out. It's going to take 5 to 10 minutes to sort.
with some food left, so sorry about that. Sorry,
No
obviously.
worries. That's cool, that's cool.
I didn't realise, so teething problems.
I guess, yeah, there's links that hopefully are readable and easy to cite for the slides, for the reference, that big reference slide and stuff. You can drop me an email at dan@datavaluepeople.com about anything. And I guess, does anybody have any questions or thoughts or, yeah, please.
When you mentioned mono,
Yeah.
how do you avoid merge held and mono-repo?
Yeah, so the question is, when you have a mono-repository, so you have like 10 data scientists working on 6 projects, and all of their code is going through that one repository, there's going to be a lot of activity in that repository, and you might be getting lots of merge conflicts or, struggling with that. So, generally, if you structured that repository right, at the beginning, when you're setting up the mono-repo, that really needs to be done by like only a few people, because that's when you're touching like all of the code in that repo. You're setting up stuff that is affecting the entire project, and you're setting it up. But once it's ready and going, really, when I'm working on a project, really the only code that I'm touching is the code in that project directory. So in that sense, there's lots of PRs going on. So you might be working quite far behind the latest main history, but as long as you're not working behind the latest changes to your particular project or direction, there isn't really like a lot of context. Yes.
What's your opinion on you didn't mention it in your platform architecture, but what's your opinion on serving and real-time serving? If you had to do it, and monitoring of the real-time serving.
Okay, cool. So that question was in that platform. What about real-time serving? Say for instance, we want to set up an ice cream flavor recommendation model, which lives on our site. And when a user comes on the site, they do some interactions, and then they send a request to our model, and it has to make a real-time prediction about what flavor they like, right? So I actually skipped. Remember those slides that I skipped?
By the way, I'm so glad you put infrastructure as code on there.
Yeah, for sure. Do you remember these slides that I skipped? Yeah, okay. Do you remember this? It says skip me, because I didn't want to do it in this. But this is my hot take for data science, right? Which is, all those projects sound different, but really they're just the same game. The game is, read some data, compute some stuff, and then write the data and make it available to the rest of the business. Now, these real-time, and this is my hot take, that you could do pretty much 90% of data science just doing that. If you want to do real-time models, that's actually not that. Real-time models don't fit into that. So actually, if you really want to do real-time models, you should really think of that as building a new app. The infrastructure requirements for that, the software engineering and the DevOps that are required to do that are way above and more complex than what's required to do this, which is read some data, compute some in Python, and write the data out. So when we've done real-time modeling, we generally do that as a separate project.
Yeah, I agree.
Yeah. And generally, what you might do is you might have the process that is training that model that is going to put in deployment might live inside here, right? The process that's monitoring that model, not real-time monitoring, but maybe doing daily, analysis of how the predictions are, the response time stuff, also might live in this, because we're going to be storing all of anything that real-time model does, we'll write it, we'll store it with that kind of thing. So we can read the data about it, we can complete some analysis, and we can look at the outputs. But the actual model itself, I think that should really live in its own project, because you're going to have service level agreements for uptime and stuff, and response time, and it's just a whole different ballgame. So, really good question. But actually, you kind of caught me. I skipped my hot take to kind of gloss over this particular fact. But my hot take is that 90% of the data science you're likely to do, and 90% of the value you get by doing this. Cool, perfect. Anybody else? Oh, yeah, please.
How do you balance that as you improve and make all these improvements to your platform? Improvement will take time.
Yeah.
You need time away from doing data science. How do you balance that versus this is needed? So they love the first two things you're doing, but now you tell them to do 3 or 4, I need to stop for a bit. Yeah.
Yeah. So this is like going back to that. So that the question was, how do you balance taking time away from your actual data science projects that are delivering value to the business to go like and take a step back and like do these platform upgrades, right? Because that's not building that platform doesn't deliver anything to the business. They're not gonna be like, congratulations. They say congratulations when you made a model that makes revenue go up 2%. That's when they really say congratulations. So I think the balance is like, once you really start feeling those pain points as a team, and you're like, oh, this is really blocking our work, then if it's the question of how do we, if you don't have the freedom just to like say to the business now, we're pausing for a bit, we have important stuff to do, then you probably have to make the case and communicate exactly why, what's going on. Our productivity and delivering value are being blocked by the pain point, and this solution will resolve that and let us go faster eventually, right? So but it is tricky balancing those two.
I would add to that, like adding like how much it's going to cost you to actually do your platform at the minute versus what the platform would, the benefits that would actually give going on to a platform as in, for example, cloud. So for example, do you actually know how much your cloud is costing at the minute? And if you're going to manage infrastructure versus standalone, like things like that, you can balance it off the costs.
Yeah, and it gets even more tricky then when you've got a whole platform built and you're like, oh, this particular bit feels like it's not working well, and you've already kind of got something. Going from nothing to something, probably easier to sell than going from, I don't know, some compute engine to Kubernetes or something. Kind of sales. Nice. Maybe I'll just, for time interest, we just call it there. I guess, yeah. Unless any more last questions. Cool? Yeah.